Hello and welcome to this new lecture. Today we are going to discuss about LLMs or large language model. In the previous video where we were discussing about the basics of generative AI, over there as well we have discussed a bit about it, but mainly we covered the basics only. In this lecture we are going to dive deeper into this topic, and by the end of this video you will be able to gain a better understanding on this particular topic of LLM. So let's start by the basic question that what are LLMs or large language model? LLMs are the subset of deep learning. So LLM and generative AI intersects with each other, being a part of deep learning. Let's have a closer look on this. So we have discussed this thing previously in the last video. So talking about LLM, it would actually not fall over here at this point. So let me erase this quickly, and to be more precise, the position of LLM within the structure of artificial intelligence would be placed over here, inside deep learning being a subset of it, and it also intersects with generative AI concept. So this is where you will have the concept of LLMs. So I hope that you are able to understand that where exactly LLM models are falling within the structure or within the large umbrella of artificial intelligence. Exactly over here being a subset of deep learning. And LLMs are large general purpose language models. Models that can pre-trained and then fine-tuned for specific purposes. Now within this particular video only, we are going to talk a bit more about this part of pre-training and fine-tuning. So just stick to the end. So there are two parts that we need to talk. First is pre-trained. As I said that these are the models which are pre-trained, right? And secondly, fine-tuning. So first of all, LLMs are trained to solve common language problems. Problems like text classification, Q&As, or it can also summarize your document or any given article, and text generation, etc. And in order to do these tasks, LLM models are pre-trained on a huge amount of data. So very large text data will be used in order to train these models. And obviously, the number of parameters will be in millions. In fact, in billions as well. And once the model is pre-trained and becomes capable enough to perform these tasks, then comes the process of fine-tuning. So the fine-tuning happens by training with a relatively small size of dataset when comparing to the dataset used for pre-training. And the agenda of fine-tuning the model is so that the model can be tailored in order to solve specific problems in different fields, like let's say retail, finance or healthcare, etc. So initially when the model is pre-trained, then obviously it will gain the capability of text classification, Q&As or text generation or other tasks. It will become good enough to do all these things. However, what if you are training an LLM to solve a specific problem, maybe for a specific field or an organization that belongs to one of these domains, maybe retail, finance, healthcare, or let's say education, etc. In that case, the model needs to be tailored, or it needs to be trained further with some specific information, and that process is called fine-tuning. And this process of fine-tuning happens by using a relatively smaller dataset, as I said earlier. So that particular dataset will not be as big as the previous dataset that was used for pre-training purpose. So in the definition of LLMs, there are two specific terms which are very important. First is large, and second is general purpose. As I told you earlier that these models are large and general purpose language models that can be pre-trained and then fine-tuned for specific purposes. And the reason why it is called large is because it is trained on large dataset, really large dataset, and secondly, it will have millions and billions of parameters to train. And it is called general purpose because it has the efficiency to solve common problems. So common problems like Q&As, summarization, text generation, etc. So these are some fundamental things that you need to be aware about before proceeding ahead with LLMs. Now let's do a quick comparison between the development of an LLM model and traditional machine learning development or training. So when you are working in a machine learning project or when you are training a machine learning model, then as a prerequisite, it is absolutely mandate to have a fundamental knowledge around machine learning, right? Otherwise, you won't be able to understand that for a specific use case or a given problem, which specific algorithm or machine learning model you should be using. Secondly, you will need training data, and using that data, model training is also required. That will need a lot of computation timing, and you will also require good quality of hardware like CPUs or high-end GPUs. And the idea of training a machine learning model is mainly about optimization or minimizing your loss. On the other hand, if we talk about the development of an LLM model, that also using a pre-trained APIs, which means you don't have to train a model from scratch by using a large amount of data set. There is no need of training billions and billions of parameters because you have this API available to you that you can use further. Going ahead on this channel, we are going to do practical projects by using pre-trained APIs like API from OpenAI, and at that time you will also be able to gain the practical knowledge around it. But for the time being, the basic things that you need to understand here, that this particular concept does not require prior ML knowledge. Secondly, what we discussed in terms of traditional machine learning development about training data, model training, computation power or timing, or efficient hardware, all these things are not needed when you are working with LLMs or when you are doing LLM development, because you have the model available and you have been given the API key for that. So all you need to do is you will pass a prompt like you do when you are chatting with ChatGPT, right? When you are chatting with ChatGPT and you are asking questions from it, all you do that you pass a prompt to it, and the model in the background is already available after lots of training, right? That model has been trained and has become efficient enough to solve your problem. So over here, there is no concept of optimization. In fact, the main idea that is going to be involved here is going to be about prompt design. So in a nutshell, you are able to understand here that compared to this ML development, it is a lot easier to work with this scenario where you get the API available to you and you get a powerful model working in the background. You just send your request through the API and you will get the response from the model. This is why it is becoming more and more important for all the data science enthusiasts to gain a good understanding around this particular topic of generative AI or LLM development. Because obviously, over here in this case, you are not bothered about gathering the training data or training the model. In fact, there is no hardware dependency as well. In this case, you will be more concerned about prompt design. And just in case you are not aware of the concept of prompt design, then it is the process of creating prompts or designing your queries in such a way that it brings out the desired response from a language model. So in terms of machine learning, you must have heard that quality of your training data defines the efficiency of your model. If you input garbage data, then you get garbage output from the model. Similarly, in this case, quality of your prompt design decides the quality of the output that you get from the LLM model. So let's assume that you are chatting with ChatGPT or Google Bard. Okay, and let me give you an example of a bad prompt. So consider yourself as a data science enthusiast, and let's assume a situation where you are seeking help from the model about job hunting. Okay, so an example of a bad prompt or a prompt that is not good enough could be something like this. You will ask the model that, hi, could you please help me getting a job in the field of data science? I'm a fresher and I want a job ASAP. This will be an example of a bad prompt or a bad prompt design. Now let's also discuss that how can you modify this particular prompt to get a very good response from the model. Okay, model like ChatGPT or Google Bard. You can tell the model, first of all, that assume yourself as a data science mentor and expert, and then you will tell about yourself that I am someone who has very little experience around data science and machine learning, and I have a very limited knowledge as a fresher, and I have done 5 to 6 projects which are there in my portfolio. So please give me the strategy or ideas around job hunting so that I can get a full-time data scientist job as soon as possible. Now this time, in case of this second prompt, first of all, you are asking the model to act like a data science expert and mentor. This is going to impact a lot on the quality of the response from the LLM model. Secondly, you are also telling a lot about yourself, that you are a beginner, you have very little experience or knowledge around the topic, and you are seeking guidance or strategy in order to land a job. You can try it out yourself on any of the interfaces of Google Bard or ChatGPT, and you will be able to observe the difference. And with that being said, let's move ahead within this lecture, and we are now going to discuss about the differences between prompt design and prompt engineering. And before we get started, let me tell you that for the time being, few of you might have some difficulty understanding it. But going ahead within this channel, I will be creating more tutorials where we will be doing some practical work, including these two concepts of prompt design and prompt engineering. So prompt design is the process of creating a prompt that is tailored to the specific task that the system is being asked to perform. Let's say you are saying that summarize the below article for me. And let's say after that you pass in the article like this. Let's say a 4 or 5 liner article. Then the model will be able to summarize this entire thing for you. It is a more essential and general concept which is used by everyone. But when we talk about prompt engineering, it's the process of creating a prompt that is designed to improve performance. It may involve domain-specific knowledge and examples of desired output, etc. So let's say this time you are creating a variable x, okay, and it is blank for now. And then your prompt is something like this. Let's say you are saying summarize the content of X. Now every time you are coming up with a new article which you want to be summarized, you don't have to create this entire prompt. In fact, what you can simply do is you can take the article and you can assign that as the value of X. That's it. And then if you run this prompt, you will get your desired output. So this was a very basic example of prompt engineering, where you are making the work convenient for yourself. It is a more specific concept that is required for specific system that requires higher degree of accuracy or performance. And as I said earlier, going ahead on this channel, I will be creating tutorials on LangChain and using the concept of prompt engineering. Then at that time, these things will make a lot more sense to you compared to what it is doing right now. So I have a humble request that in case you are new here, please consider subscribing. It is going to be absolutely free for you, but it will encourage me a lot. And secondly, please consider pressing the bell icon as well. You will get notified as soon as I am uploading any new video or any new tutorial. And the last thing that I want to talk about is the difference between a base LLM and instruction tuned LLM. Let's try to understand these things one by one. So a base LLM basically predicts the next word based on the training data. Let me give you a super quick example. It may have happened with you a lot of times that when you are typing an email on the Gmail application, okay, and as soon as you write something like this, let's say, please find the required, as soon as you write this much, the Gmail application starts giving you suggestion like this: details attached to the email. This will be the suggestion by the Gmail application, this particular line, okay. And in most of the times you will observe that the suggestions by the Gmail application will be very accurate. It is because this particular base LLM has seen a lot of drafts like this, where a lot of people write the email in the same format, that please find the required details attached to the email. And this is why as soon as you type this much, rest of the message will be suggested to you by Gmail application. This was a very typical example of a base LLM. And this kind of base LLM was also used previously with Google search engine as well. And there was a problem with that. I'll tell you what. So initially, if you remember back in time, when we used to do a Google search something like this, that what is the capital of India? Okay, if your question is something like this, then obviously in response, you will expect the answer, the capital of India, right? But what Google search engine used to do is, it used to give you similar questions like this, what is the currency of India? Or maybe like this, what is the population in India? Okay, so this was the problem earlier. However, now Google has improved it, and now if you will do the same search, then you get the answer like this. But this is a recent modification that has been made by Google team. Otherwise, initially it used to give you questions like this: what is the first capital of India? What is the capital of 29 states in India? Something like this. Okay, so this part on the top is a recent modification by Google. It was not there earlier. It became possible by the advancement in the field of LLM models. So in contrast, if we try to talk about instruction-tuned LLMs, then it tries to follow the instruction actually. We start with a base LLM like we were using over here. So it is not that Google has absolutely discarded the previous model. Okay, that will be used, and then it will be trained on huge amount of text data and further fine-tuned with input output on instructions and attempt at following those instructions. So that model, that specific base model, will be trained on data based on input output instructions. Okay, that will look something like this. So if we say what is the capital of France, okay, if this is the input, then the answer will be the output. The capital of France is Paris. So this will be the type of data on which the base LLM model will be fine-tuned further. Okay, so previously the base model had the information or knowledge of language, but it is just that it was lagging to understand that how to answer a specific question which is coming as the input from the user. And this is where we further train the base LLM model and we fine-tune it to achieve the instruction-tuned LLM that can follow instructions, that has the capability to come up with a correct response with respect to a given question. So I hope that it provided you some clarity around these two, base LLM and instruction-tuned LLM. And with that being said, we are coming to the end of today's topic. We have covered a lot of things today as well. And I'm starting from absolute basics, okay? Because just like most of you people, I'm also trying to explore this field of generative AI and LLMs and prompt designing, etc. And what I have decided that whatever I learn in this field, whatever projects I do, the theoretical knowledge or the practical knowledge, I will try to share everything at least as much as possible on this channel to educate my audience, so that you should not be struggling when you are appearing for a data science interview and you are being asked for your understanding around these latest technologies. Again, if you are new here, consider subscribing to the channel to support my work, and I thank you very much for watching till the end. You have a nice day ahead.